Chapter 6, Modeling Random Events, the Normal and Binomial Models. In this chapter, we'll look at discrete versus continuous random variables, how to apply a normal model to find probabilities, how to apply a binomial model to find probabilities. We're going to start with the discussion of probability distributions. So what is a probability distribution? Well, it's gives you all the possible outcomes of a random experiment and the probability of each outcome. A probability distribution must satisfy that all probability values must be between 0 and 1, and the sum of all p of x values must equal 1. So when you add up all the probabilities of the events in the sample, it must add up to 1. Probability distributions are usually presented as either a table or a graph. So let's look at some examples. Suppose our experiment is rolling a fair die. Then the table below displays the probability distribution. Now notice this table tells me all possible outcomes. So x is an outcome. The possible outcomes are 1, 2, 3, 4, 5, 6. And it gives me the probability of each outcome. In this case, each outcome is equally probable with probability 1 over 6. Now remember, the other condition to be a probability distribution was that if I add up all of the probabilities, it adds up to 1. Now you can see if I add up all the probabilities in my probabilities distribution, they add up. I have 1/6 added to itself 6 times, and so that's going to equal 1. Now I can use the probability distribution to find probabilities. So for example, what's the probability of rolling a 5 or a 6? Well, rolling a 5 or rolling a 6 are mutually exclusive events. So to find those probabilities, I can just take 1/6, the probability of rolling a 5, plus 1/6, the probability of rolling a 6. So the probability of rolling a 5 or a 6 is 2/6, or 1/3. Here's an example of a probability distribution given to us as a graph. Again, this represents a probability distribution because each of the possible probabilities are observed by reading along the y-axis, looking to see where it meets the y-axis. And if you were to add these possible probabilities up, they all add up to 1. So this tells me the possible outcomes in my experiment are 1, 2, 3, 4, or 5. These are the number of stars that a reviewer gave a book. And it gives me the probability of each of those occurring. Let's estimate the probability that a randomly selected reviewer gave this book a 3-star rating. Well, the 3-star rating is here, and so if I wanted to know the probability of getting a 3-star rating, I'm going to look over to the y-axis, and that looks a little under 0.1. So we're estimating, so we'd say that's about 0.1. When we talk about numerical variables, there are 2 types of numerical variables that we could be talking about. The first is a discrete variable. These are variables that take on numbers that you can list or count. So for example, the number of siblings someone has, the number of songs on an album, or the number of bowls in a cupboard. These are all numbers that you could list. For example, the bowls in the cupboard, maybe there's 1 or 2 or 3 or 20, right? They're just numbers that we could list or count. A continuous variable, on the other hand, cannot be listed or counted because they occur over a range of values. So for example, the height of a basketball player, the weight of a sandwich, or the volume of coffee in a cup. Each of these can range over a range of values, and we can't just list all the possible, for example, all the possible heights of basketball players. Let's label each of these variables as discrete or continuous. The number of cars owned by a household. So you should ask yourself, is this something that I could list out with counting numbers? So if I'm talking about the number of cars in a household, well, yes, I could list that with counting numbers, right? A household could have 1 or 2 or 3 or maybe 10 cars. But I could list those numbers out. That's not over a range of values where I need to be able to include, say, the decimals between those numbers. So this is going to be discrete. What about the litter size for a dog? Again, those are counting values. The dog could have 1 or 2 or 3 puppies, right? So on. So this is going to be discrete. What about the length of a pencil? Now the length of a pencil could be measured in, say, inches or centimeters, and we could have decimal values there. So the length of the pencil is going to range over a set of values that I can't list out one by one. So that's going to be continuous. What about the time it takes someone to commute to a job site? This again, the times are going to range over a variety of times, and they're not times that I could just list 10 minutes, 11 minutes, 12 minutes, for example. Maybe it takes 10 and a half minutes or 10 and a quarter minutes. So in this case, this is going to be continuous. How about college credit hours completed? The number of credit hours you complete is a whole number, and so I could list the possible credit hours completed one by one. And so this is going to be discrete. The number of pets owned by a student is another example of a discrete variable. We could list out the possible number of pets one by one. How about the height of a building? Generally speaking, when we're talking about height or weight or length or time, those are all examples of continuous variables. They take on values over a range. I couldn't list out the individual possible values all at once. So this is continuous.